Hello, and welcome to this session on data modeling using Microsoft Power BI. In this session, we will talk about data modeling concepts such as normalization, data and dimension tables, primary and foreign keys, and cardinality as they are used in Microsoft Power BI. Microsoft Power BI is a powerful business intelligence tool that enables users to visualize and analyze data through interactive dashboards and reports. It integrates seamlessly with various data sources, allowing for real-time insights and data-driven decision-making. Power BI offers user-friendly features like drag and drop functionality, AI-driven analytics, and robust sharing options. It is widely used by businesses to simplify complex data and enhance collaboration. Today, we will not discuss how dashboards are created. We will discuss how data is organized within Microsoft Power BI. In this view, we are seeing two types of tables, the dimension table and the data table. The calendar lookup, the customer lookup, and the product lookup are called dimension tables. These tables provide details of a specific dimension, namely date, customer, and product. Details of the customer are education, address, first name, last name, and gender. Details of the product are product color, product description, product name, product price, and size. The sales data table is called a data table because it provides data on sales of different products and is not concerned with details of specific dimensions such as date, product, or customer. In this view, the relationship between the tables has not been defined. If we create a table in the dashboard with product name and sum of order quantity, we will get the same value for each product, namely 2630. We will now establish the relationship between the three dimension tables and the data table. As you can see, the customer lookup table, the calendar lookup table, and the product lookup table are connected with the sales data table now. This is now a data model because relationships have been established between the dimension tables and the data table. We can now access data from all the four tables without having to merge the tables into one large table where several values would be repeated, causing the size of the table to become very large. The calendar lookup table is connected to the sales data table through the date key. When you hover over the connection, the connecting key gets highlighted. The customer lookup table is connected to the sales data table through the customer key. As you can see, the customer key is highlighted in both the tables. If we were to bring in a few more dimension tables and two sales data tables, the relationship view would look like this. This process of establishing relationships between dimension and data tables is called normalization. It reduces redundancy or repetition of data and preserves data integrity. How is redundancy eliminated? In a data table, a dimension is likely to be repeated. For example, a customer makes purchases several times, and the customer's name will appear several times in the data table. If all the details of the customer appear on the table every time the customer makes a purchase, it will cause repetition of data or redundancy. Instead, if only the customer key is mentioned in the data table and the customer key is linked to the customer key in the customer dimension table, only one field, namely the customer key, needs to appear in the data table. When tables are organized in this way, eliminating redundancy, the process is called data normalization. In the sales data table, each product is represented by a product key. Each customer is represented by a customer key. Each territory is represented by a territory key. It is not necessary to include all the details of the product, the customer, and the territory in this table. The details of the customer are contained in the customer lookup table. The details of the product are contained in the product lookup table. Structuring data in this form eliminates redundancy, and every data element is required to be stored only once in a table created for a specific purpose of storing data relating to that dimension. This may not seem like a big deal if you are dealing with a few hundred rows of data, but if the table size goes into thousands of rows, data redundancy could become a major problem. In the view above, the relationship between the sales data table is established with dimension tables through the date key, the customer key, and the product key. These keys, when present in the dimension table, are referred to as primary key. These keys, when present in the data table, are referred to as the foreign key. In this set of tables, the relationship has now been established. Let us see how the table containing details of product and sales appears in the dashboard view now. The correct sales values for each product are now reflected in the table and not the total sales number as we have seen in the previous table. The sales data table is linked to the product dimension table, and therefore in the dashboard view, the sales table by product is appearing correctly. The customer dimension table is connected with the sales data table through the customer key, and hence the table of customer-wise sales is appearing correctly in the dashboard view. The calendar lookup table is connected to the sales data table through the order date key, and hence the table of order quantity by date is appearing correctly in the dashboard view. The product category table is connected to the product subcategory table through the product category key, and the product subcategory table is connected to the product table through the product subcategory key. Hence, the product category, product subcategory, and product details are appearing correctly in the product table in the dashboard view. The sales territory dimension table is correctly linked to the sales data table, and hence the sales by territory table is correctly appearing in the dashboard view. Cardinality refers to the uniqueness of values in a column. Ideally, all relationships in the data model should follow a one-to-many cardinality, which means one instance of each primary key and many instances of each foreign key. What do we do when there is a one-to-one relationship? In this view, we have two tables, the product lookup table and the product price lookup table. Both are dimension tables concerning products. These two tables therefore have a one-to-one relationship. It is possible to establish the relationship between these two tables through the product key. Better solution is to simply merge the tables. This will not cause any data redundancy since the data sets in the two tables are distinct but are relating to the same dimension, namely product. Let us now look at an instance where we have two data tables. It is not possible to establish relationship between these two tables because it would amount to many-to-many relationship, which is not feasible. The solution is to establish the relationship between the two tables using a dimension table, as we have done in this video. That wraps up today's session. I encourage you to explore Microsoft Power BI further and examine the different facets of this powerful business tool. Thank you for your time and attention. I wish you success on your analytics journey.